Hello, everyone. In this video, we want to look at the conversion between moles, molecules, and atoms. So to do so, we have to there's a chart here you can take a look at. So mole is the most important unit in chemistry. So from moles, you can go different routes. You can either go and find the grams or vice versa, going from grams of something to moles of something, or you can go from moles to molecules and atoms, or you can go from moles to the liters, the volume of a gas at STP. But for now, in this video, we're only focusing on this portion, which is going from moles to molecules and atoms and going backwards. So I have other videos that it's showing the convergence between moles to grams or moles to liters at STP. So if you want, you can watch the rest of the videos. I'll tag them here. But for now, the focus is just between moles, molecules, and atoms. So first of all, we have to define what mole is. So 1 mole of a substance is equal to 6.02 times 10 to the 23 particles. So particles are little things that it's like basically so hard to see them, and we need a microscope for seeing them. So 1 mole of a substance is that many particles. So, and this number is considered as Avogadro's number. So let's take a look at some examples of particles. So for example, protons or neutrons or electrons are particles inside an atom. So protons and neutrons are inside the nucleus, whereas electrons are floating around the nucleus. So these are all particles, tiny. And then photons is the smallest particle of light. And then we have molecules and atoms. So these are all considered as particles. So for example, we can say 1 mole of electron, which is a particle, is made from 6.02 times 10 to the 23 electrons together. So if you put that many electrons together, that's considered as 1 mole of electron. Or let's say 1 mole of water, a molecule is made from 6.02 times 10 to the 23 molecules of H2O. Or we can say 1 mole of sodium is made from 6.02 times 10 to the 23 atoms of sodium. So you might think that here in the second and third examples, I didn't say water is a molecule, or I didn't say sodium is an atom. I just said water. And then how come we're using molecules for that? The reason for that is because when they say 1 mole of H2O, you understand H2O is a molecule. That's why we have to say it's made from this many molecules. But then for the next example, when we say moles of sodium, sodium is an atom. It's not made from different atoms. It's just one single atom. So it's not a molecule. That's why we say 1 mole of sodium. Technically, what we mean is 1 mole of sodium atom is made from this many sodium atoms, basically. So again, this is a chart we have. Here, we're going to do some examples going between moles, molecules, and atoms, and maybe working backwards too. So we just keep this for now here. And let's look at the first example. Here, the example is find the number of molecules in 3.2 moles of HCl. So the number of moles is given to us, and we want to find the number of molecules. So as you can see in the chart in the bottom, we're just doing one step going from moles to molecules. And as you can see, HCl is a molecule, so it's perfectly fine. We start from 3.2 moles of HCl. And next step is to cancel the moles and convert it to molecules. So moles has to go at the bottom, molecules has to go at the top. And we always know that for every 1 mole is always 1. There's that many particles, 6.02 times 10 to the 23 particles, which is in this case molecules in there. So this way mole can cancel with mole, and we get our answer in molecules. So this way we find the number of molecules of HCl. Let's take a look at another example. Here it says find the number of atoms inside 1.56 moles of magnesium. So here we're dealing with magnesium, which itself is an atom. So as you can see, I've put another line going straight from moles to atoms using Avogadro's number. And you use that when the element, the substance we have itself is an atom. So for example, magnesium is an atom. It's not made from multiple things. So it's just an example of an atom. So therefore, we start with the number of moles of that. And then next step, we want to cancel the moles and convert it to atoms. So this time we can go directly from moles to atoms. So we say 1 mole of sodium is made from this many atoms of sodium. So moles can cancel out. And then this way we find the number of atoms of magnesium. But then what if we have the number of moles, but this time for a molecule, and they're asking us to find the number of atoms? So this is a different scenario right now. So we can take a look at an example. Let's say find the number of atoms inside 2.81 moles of CO2. So as you can see, CO2 is a molecule itself. It's a compound. It's made from different atoms. And we want to find the actual number of atoms in there. So that's why we cannot go we can't do this in one step. First, we have to go from moles to the molecules in the bottom. You can see it in the bottom root, from moles to molecules first, and then you can go from the molecules to atoms after. So we start with the number of moles given to us, and then next step is to cancel mole converted to molecules. And then we know for every 1 mole, there's that many molecules. So moles can cancel out. And now we know the information we know how many molecules of CO2 we have. So next step is to cancel the molecules and now find the number of atoms in there. So as I said, you have to count it here. So we say, for example, if we have 1 molecule of CO2, you can simply count and see how many carbons, how many oxygens there is. So in total, there is 3 atoms. So this way, molecule can cancel with molecule, and we end up getting the number of atoms in this whole CO2 once we have the number of moles of CO2. Now, let's look at some examples that we're working backwards. So for instance, they asked us to find the number of moles in 4.16 times 10 to the 22 molecules of KBr. So this time the molecules is given to us, and we have to go to moles. So we have to go straight in one step, going from molecules to moles, because we know the molecule KBr is a molecule, and we want to just find the number of moles of that. So we start with the number of molecules. Next step is to cancel molecule. So put it at the bottom. Mole has to go at the top. And again, as we said, always it's for every 1 mole, there's that many particles. So the mole is always 1. And then 6.02 times 10 to the 23 is the number of molecules in there. So this way molecules can cancel out. And now we know the number of molecules. And this is the answer to the question. Let's look at another example. Find the number of moles of HNO3 having this many atoms of oxygen. So this time, they're giving us the number of atoms of oxygen inside a molecule of HNO3. So this way I have to go backwards, but I have to do it in 2 steps. So I have to go from the number of atoms, then go to the molecules of HNO3, and from there I have to find the moles of HNO3. So we start with the atoms of oxygen, and then next step is to cancel out atoms, and go to molecules. So atom has to go at the bottom, so it can cancel out. Molecule has to be at the top. And then we can simply do the counting, and we know for every 1 molecule of HNO3, there's 3 oxygen atoms in there. So this time they're not talking about the number of atoms in total. They're just particularly mentioning the number of atoms of oxygen. So there's only 3 of them. If the number of atoms was for just in total, like in general, and it wasn't giving us oxygen or anything, then we had to say 5 atoms at the bottom. But right now, because it's specifically talking about the number of atoms of oxygen, we just count the oxygens within the molecule. So there's 3 oxygen atoms for every 1 molecule of HNO3. This way, atoms can cancel out. And then now we have, technically by now, the answer is just a number of molecules of HNO3. Next step is to cancel the molecules and convert it to moles. So molecules has to go at the bottom, moles has to go at the top, and then same idea. For every 1 mole, there's always this many particles. So it's 6.02 times 10 to the 23 molecules. So this way, molecules of HNO3 cancel out, and our final answer would be in moles, for moles of HNO3. Okay, and that's it for this video. I hope you found it helpful. If you liked the video, please like it, and please subscribe to watch more videos. I'll be posting more. Have a good one.